and start getting ready. Give it another minute for people to connect up. Okay, so we'll go ahead and get started here. So welcome to class again. Good to have you all online, or those of you who are here online. So today's devotional is John 1, verses 10 through 13. He was in the world, and the world was made through him, yet the world did not know him. He came to his own, and his own people did not receive him. But to all who did receive him, who believed in his name, he gave the right to become children of God, who were born not of blood, nor of the will of the flesh, nor of the will of man, but of God. So two key things that I can see in this verse, and please chime in if you have some other observations, is that we are children of God. The other thing is that, and we should have great gratitude and praise his name that we are children of God. And the other thing is that it's not of our own doing or any humans doing, but in fact is from the work of Jesus. That we are sinners. We have our issues with pride or selfishness, and indeed can be hypocrites, that we are children of God, but sometimes our actions don't always reflect that we are, but it is something that we should strive for. So any comments or questions regarding this devotion? Okay, we'll go ahead and move on here. So the midterm is now in Canvas, set for Monday, April 6th. Again, that's going to be a situation where you can take the midterm at any time up until midnight on Monday. So it doesn't have to be done on Monday, but any time between now and Monday midnight, go ahead and take the midterm. The midterm cover is, look at the study guide, and that's available on campus, both in the announcement and in the modules section. Let me know if you have problems getting it, but I think everyone has gotten it at this point. And that's the key thing. And then it will be through the chapter on design. So it won't be implementation nor the testing that we have recently covered. So those will not be included in the midterm. And then my goal is to finish up the UML design exercise reviews, and then we will also start diving into the software requirements specifications. And if we have time, we will look at configuration management, but I doubt we'll have time to get that far today. So.
Can I quickly ask?
Yes.
Is my mic available? Is my
yes.
mic? Okay.
You're on.
What's the format of the questions for the midterm? Is it going to be essentially just text boxes where we enter our answers?
Yes, there'll be text boxes that for short answers. So those of you my operating system class recognize that. There is one design problem. So that's a good question. I'm glad you asked. Where you will using either your favorite tool or just writing it and taking a picture of it and submitting it you will submit a design problem as the last question. So it's good that we're reviewing the UML design review, doing the UML design reviews, because that is exactly what you will be doing in the last question. And it actually is worth a fair amount of points. So very much an incentive to pay attention to what we're doing today.
Okay, I'm also wondering, what will the time limit on that be?
It's a 1 hour time limit.
Okay, and would you say that should be plenty of time?
Yes. My experience is, even with the design problem, that all the students finished well ahead of time. I think a few students may have taken more than a half an hour in the past, but not too many. So you have an hour, but I have seen most students turn in their work in less than half an hour. It may have been that they didn't do as complete a job on the design, but I think the hour should be plenty of time to complete the midterm. So my goal is not to have speed tests, which is what I had a lot in my experience in college, and I don't want to repeat that for you. I want you to be able to have a chance to think and really show what you know, and not just be an indication of how quickly you can do things. I want you to be able to have the ability to really think things through and do a quality job rather than just a very quick job. Daniel, I believe I already went over your design. Is that correct? Are you online here, Daniel?
Yes, you have.
Okay. So I believe Jason is the next person up. Is that right, Jason? I'm sorry. Yeah.
Oh, definitely not. Yeah.
Okay. Oh, that's right. Because I remember your comment, Saved by the Bell kind of thing.
Yep.
So here you have a state diagram. Moving up, stopped, and
We
moving
can't
down.
see your screen
That's
in
not
case you're
showing.
Oh, I'm
wondering.
sorry. Let's share the screen. Thank you. Here it is. Where is it? Here. Okay, can you see my screen now?
Yes, indeed.
I can see it.
Great. So
probably needs to be
thank you
zoomed
for
in a
pointing
bit.
that out. And so here we have the state diagram for the elevator. We have that it's moving up, stopped, or moving down. And when it reaches the floor is the event that transitions from either moving down or moving up. Reach floor B, which is, I assume, the destination floor. So that looks good. Let's see. Your transition to moving up or down is dependent on whether a floor button is pressed where it's greater than the current floor at M or less than. Okay, so that's a guard condition of which button up or down, and that would start either moving up or down. And then I can't quite read it because it's small. So Jason, can you fill us in on what the events on the left are?
One second, sorry.
Yeah.
Then lost it. Yeah, you should be able to zoom it in, otherwise I can share it.
Okay, let's go ahead and zoom.
I remember how photos, yeah, just have a slider.
Oh.
Yeah, it meant to be cropped in, but evidently I didn't.
And every time I click on it. Okay, I'm a little too far out, I think. Okay. So let's see. You press the call. Okay, so that's the call buttons from the floor. Yes. And if it's greater, moving up, moving down. And then arrive at floor goes to stop. And then we have stopped at C, continue to B.
Yeah, the left one is supposed to be the state if you request the elevator while the elevator is moving in that direction but hasn't reached it yet.
Oh, so that you're
So
in,
that one wasn't super clear.
basically you're in a waiting state. Let's see. It's somehow queued up.
Yeah.
So that might
would
be
effectively add it to a queue.
right. And so that may be an event that's basically sending an event out to the queue. That may not necessarily be, I would say, a state in this elevator. It probably is an event that's sent to another object that you don't have a diagram for at this point, but I think that would be it. But yeah, a good job on the elevator problem. And let's see if I can get to the next diagram directly from here. Let's see. Apparently not. Okay. So we're going to Daniel's presentation, and again, I need to share that. Okay. So can you see the UML class diagram?
Yep.
Good. All right. So this is Daniel's submission.
That's correct.
And so we have the door and then a controller. That's basically the controller that's controlling everything.
Yeah, it's like a button or the internal logic of the elevator.
Yes, right. So that's again, I was saying a supervisor or a controller object is very common in a real-time system like this, but also in any system that has multiple coordinating classes that need to coordinate. A lot of times you will have an Uber class that does the coordination between the different classes and the timing of when things happen. So that's a very common solution, as I mentioned yesterday, I believe. And then we have the elevator, which has as an attribute the current floor, and then it has a button method, which I'm not sure exactly what the button method does. Maybe it lights the button, I'm guessing, in the elevator, and then a move operation. And there you would assume that they would have an argument that would be move up or down, maybe as a parameter that's passed to the move method. We have the button, which has which floor it's on. The desired floor, that would be the integer for a button in the elevator, I would assume. Oh, I guess, or the floor. I guess it would be the floor as well. And then the button light, whether it's on or off, and then the direction of the button. So that would be one from the floor. And then we have call from floor, call to floor, illuminated, and deilluminated. So here you have, instead of a toggle, you actually have separate methods for each. So that's another approach that could be taken. Good. And I was able to just use the arrow key to your state diagram. And so again, very common. This is looking like a flow chart, which is not bad. I mean, having a flow chart is good. It's not a UML diagram, but it is an effective tool. But this is not strictly a state diagram. If you had a state diagram, remember that you're talking about the state of a specific class or instance of an object. You are not talking about multiple classes. That's a sequence diagram or flowchart. Sequence diagram is the UML component, but flowcharts are effective as well. They're just not part of the UML family. But again, I have no problem with using the so-called old school flowchart. So that's essentially what you have here is a flowchart of operations of what's happening. So good. And then hopefully this is Isaac's class diagram, and we see the elevator. I am assuming the relationship contains that. So probably it would be the open arrow here because I assume it's an aggregation rather than a composition. But again, that's just a syntactical thing that it'll take a while for you to get used to. And then the floors also have buttons. Yes. And then we have the inner button and the outer button. So I assume, yeah, the inner button is the one inside the elevator and the outer button is the one that's on the floor. Good. So we have a state transition diagram. We're waiting and the button is pressed. And then so this is the state transition diagram for the elevator, correct? Isaac, I believe that's correct.
Yeah.
And it's moving and then it's arrived. We open the door. So open door is an action. It should actually probably be a state that you're at the destination floor, and then the action that happens in the at desired floor is open door. So that should probably be the action, not the title of the state. And then you have a time delay in which you close the door, and that would be getting ready to move or in the closed door state. There is some state there that I understand what the state is, and right now it's escaping me what the correct term is, but it's basically sitting at a floor and the designated amount of time has transpired, and you want to close the door. You're not necessarily moving, but you want to close the door and go into the waiting state. So actually, it's a good question. It may be your waiting state. Depends on if you can have, if the waiting state, the door has to be closed to be considered to be in the waiting state or not. Maybe you could be at the floor. So the closed door state may go away, could go away possibly, depending on what you want your implementation to look like. Okay. Good. And then we have Jessica's. And so we have an actor here. So this looks like not the class diagram that we were looking for, or maybe a mixture.
Use case diagram?
Yeah, it looks like a use case diagram with the actor, but then we have buttons and relationship between buttons as well. So we have a list of buttons and a button light program. So Jessica, can you fill us in on what is the characteristics of the button light program?
I should have. You should have had a second PNG thing that was the button light program or something.
Okay.
Yeah, but yeah, this was it. I had just gotten new free program, was struggling with figuring out how the heck it worked.
Right.
Yeah.
So then on floor, what does that represent?
Well, it's mainly the program just detecting if it was on the floor or not. This is, yeah, just on the floor that was determined by the button. Yeah, it's not a good diagram.
Yeah, so what I'm seeing is you again, you're starting to drift, and it's very common when you're new to UML diagrams. This is almost a flow chart as well, kind of, but it's got a mixture of things. So yes, definitely something to keep in mind is that UML diagramming conceptually will sound easy, but it takes practice to get good at and to really apply the techniques. So that's good. And we're going to look at your other diagram. And so this is your button light program.
Yeah, basically it was just detecting is if it's on the floor, not if it's on the floor, the light goes off.
Okay,
That's
so
pretty much.
and this is meant to be a state diagram. Is that right, Jessica?
Yeah, I'd say it's a bit more state.
Yeah, it's a bit more state,
that stuff.
but the toggle light again should be the action that happens within the state, not necessarily the state itself. So that would
Right.
probably be on, and then the other state might be off, and then the floor state question mark at floor or not. Again, those are probably events that transition you between the states.
Yeah, I'd never done UML before.
Understood. You have a lot of students in the same boat as you, so you're not alone. So hopefully as we go through these diagrams, it will help you in seeing how these are used by looking at your fellow classmates things. And as we go through lots of them, it becomes basically our mini lecture that you can see how your other fellow students have addressed them, and take nuggets from what you see that you like that the other students have done, and you will get better at it as time goes along. So here we have a UML diagram. So here we have, it looks like a state machine here. We see the circle, the solid circle with the arrow down, that's the entry state. We see the diamonds, which leads me to believe this might be getting to be kind of flowcharty. Let's take a look. Stationary design and doors open. Inside or outside button activated. So that is your event. So that would be labeled on the arrow, not in a bubble. And I would say that it would probably be two separate arrows, one for an inside button activated and one for an outside, just because your states would be different, but maybe not. Let's take a look. Let's keep going down. Then we seem to have some type of decision triangle that we activate the button light or enter floor and direction. So Micah, can you fill me in on where we're going? Do you have a microphone? Otherwise, you can chat, and I will fill the rest of the class in. So I'm going through the list here and seeing if Micah is online. Oh yes, he is. So Micah, if you could chime in with how this activate button light and enter floor and direction, what is the design concept there?
He's in chat.
Yeah, it looks like you put it in chat.
Oh, okay. I see the new message sign. Thank you. There we go. They were supposed to be activated together. Okay, yes, that's what it sounded like. So what, Micah, what that tells me is that enter floor and direction and activate button light are actual actions that will happen within the state. So that should be a single bubble with some title about what state you're in and what happens in here. So that's what kind of gives this a flowcharty feel to it, as well as the diamonds, because you actually have actions involved in these bubbles, and so it really is a flow chart. but you're sort of again in that same realm where you're half state machine, half flowchart, and it's common. That is what most state diagrams look like when you're first starting. And key thing here is you should be looking at a single class and not multiple classes. If another class is involved, it's usually some event that in your actions on your state that you're firing off. And we'll actually, I was going to say we'll talk later about it, but let's talk about that now. So this is a great point to do this. And then we have your button class and your elevator class. You don't have the relationships between them, but I can see you're getting started where you have the attributes and the actions that those particular classes will do. Then you add in the relationships, inheritance relationships, relationships between the classes, aggregation and composition, those kinds of things. So anyway, so one thing that will help you with a state transition diagram is, again, think about it as looking at an individual class and creating actions on those classes. Now note that those actions can cause behavioral changes in multiple different classes. For instance, the elevator reaching a floor will affect the button, will affect doors. And so what is generally done is that there'll be a list of events or actions that you will list out in a single document that then are used in multiple places in your state diagrams. And in fact, I've seen it, in fact, I have done it this way where I've actually labeled them E1, E2, E3, and then have a description of those events. And then in my diagrams, instead of having the full text there, it'll be E1, E2, E3. Now it makes it harder to read, but it makes it easier to create. So again, that's sort of the trade-off. But there you have a consistent set of events that will happen across all your different classes, and then you plug them into your state machines so that you know that when the elevator reaches a certain floor, that will affect the door, it'll affect the buttons, inside buttons, outside buttons will change based on reaching a floor. So you can see that you will have a list of events that you need to keep track of. And then you can actually look at each of your state machines once you have a list of events and say, what effect does this have on this class? And one of the answers might be, it has no effect, I don't really care, or that will make me transition to this state. And you can go through each of those different events, and then you can also realize that all those events are potentially significant to all or some of the classes. So that also points out, so as I'm going through these diagrams, you've noticed that I can look at these diagrams and get the main point, but oftentimes I'll have questions, and that is sort of a nature of UML diagrams. It's one of those things where it's a picture is worth 1,000 words, because you can get a graphical or pictorial representation of the design, but the granularity of the details is not there. So what you would generally see is supporting when you get, and that wasn't asked for in this assignment, so it's not something that I expected any of you to have done. But when you take these UML diagrams and put them into your software design document, SDD is generally, or software design specification, SDS, but you generally have heard software design document, but either of those acronyms are commonly used. You would take these class diagrams. So for instance, for a class diagram, you would actually have the class diagram and the relationships, but then you would have in text a short description of the purpose of the class, its interactions, and so you would actually have a section or a paragraph, but generally you would put a section header describing each of the classes in your UML class diagram so that you can get the granularity of detail that you can't see in the diagram. Again, with the state transition diagram, I talked about having a document that describes all the events. You could also have in your design document a description of what the event represents. Generally, the state represents what a state and event represents. You definitely want to have a description of the events and a coalescing of all the events for your system. But your states, you also may have need to have a description if the titles of the states aren't descriptive enough to fully explain what the state is. You would have, again, supporting text for the states for that diagram. So for instance, as a counterexample, something like a light or a button being on or off, well, that's pretty straightforward, and you may not need to have descriptions of the states because it's obvious. On is on, illuminated, and off is off. But that is sort of a call. But basically, you would have your diagram, and then you'd have supporting sections of text that expands on the elements of, and it's a very powerful design documentation tool to do it that way, to have the diagrams and then have the sections do that. I know that right after I finished my master's program, I worked on a project. So I worked for Lawrence Livermore National Laboratory, and I was working on a project where we were deploying the system to a lot of complexes in the Department of Energy complex. And so one of them, the facilities that I deployed this was at Rocky Flats, which is was a facility that is now shut down that was in the Denver area of Colorado, in Denver, Colorado area. And I actually, gave the design documentation to all the different sites so they could see the design, and if they needed to do any modifications of the system or even request modifications to the system, they could see where the design was coming from and how it was laid out. So I didn't think much about that. But so that was early on in my career. I would say that was roughly 1985. So around comes 1995, and I'm doing another project in Los Alamos National Laboratory. And this is a big consortium effort where we're working with GM and Ford and Pratt and Whitney, all kinds of manufacturing companies on this initiative. And I start working with the employees that were going to be on our team in Los Alamos. And before I said my name, and before I even finished saying, who I, talking about who I was and what my experience was, immediately someone in the group says, "Oh, I know you. You're famous." And I'm like, why? And it turns out that the person that I had given the design documentation, Rocky Flats, had taken that with him to Los Alamos Lab because he had moved to Los Alamos Lab. And he was using my design to teach a class in design and using that as a benchmark of how the design should be. And I was just like floored. This little design document that I had done had actually become teaching material for the Los Alamos National Laboratory, at least the area that he was doing teaching. So it is a very powerful design technique. And so hint, hint, as you start looking at doing your software design document, this would be a very useful tool. Now, at this point, I am not thinking about having a design template and leaving it up because generally your design document, companies will generally have templates, but a lot of times you're always adapting a design document to your particular design and your techniques of design. So at this point, I don't have a design document envisioned, but I may change that later on. But certainly having UML diagrams with sections that describe each of the classes and events in the state diagram would be useful, and having a document of the various events that are part of your system. So let's see, let's go back to submissions, and then we have Addie's elevator class. Looks like, I think you see that, at least that's the indication I have. And so we have her class diagram here with the elevator. It's composed of one or more doors. I believe the solid diamond should be on the other side of that relationship. I may be wrong. And then we have, and then the elevator has to have a door. And then we have the aggregation of buttons. That's interesting that it's an aggregation and not a composition. So I would have a hard time thinking that you could have an elevator that does not exist without buttons. But I guess if you actually had a manual elevator and an elevator operator, and he's starting and stopping it manually, maybe it could exist without a button. So then there again is a design question whether it's a composition or an aggregation. And then we have floors. And the aggregation of floors into the elevator, again, that might point to a building, because I'm not quite sure an elevator is aggregating floors. So that might point to another class. And but anyway, good class diagram. Let's see, and I don't believe you had a state diagram. No, okay. And then let's go to a cheers. And I need to share. All right, so I believe I'm sharing O'Cheer's diagram. Here we have, again, yep, he has a building with elevators. That would be, I think, a aggregation relationship. So I would expect an open diamond there. Floors, again, would be probably a composition or aggregation, probably a composition, I would think. Yeah, because you have to have at least one floor to have a building. And then the doors, so the elevator has a relationship to the door or is composed of a door. Again, those relationships. We have a button, and then we have an inheritance. So that should be an open triangle, and I can imagine that maybe your tool doesn't support that too well, but that should be an open triangle thing that shows the inheritance. But again, I can see that easily here, that you have the inside button and outside button inheritance from button. So nice job. And then let me go back to PDF. Let me reshare my PDF viewer. Okay, I think I'm sharing my PDF viewer again. And yeah, so again, common problem again. This is a flow chart, probably a pretty nice flow chart, but it is a flow chart, not a state diagram, but that's fine. And then we have elevator, button, and floor as your classes. Again, you may want to have a door as a class, but good first cut. Oh, and then we have someone who uses the tool that I use. So let me share that. So this is using Visio, which is the tool I was using. Here we go. So here's his class diagram. So this is using Microsoft Visio. So Richard, were you able to get Visio off the free webs tools from Microsoft that I sent off earlier? Is that where you got this from, or did you end up purchasing this? So is Richard online here? Let's see.
I don't think he's online.
Yeah, I don't see him. Okay. So anyway, here's his floor and his elevator. He's got a bunch of methods that happen and attributes. There is no division, so it's kind of hard to see. So there should be a line. Oh, maybe there is a line. But okay. Yeah, there is a line between them. Is door open? Is door locked? Yeah, it looks like he's got the attributes and the actions kind of mixed together in them. So it should be the attributes or properties of the object on the part above the line, and then below it, the different things that can happen on that class. So let's bring up his other one, the state transition diagram. Okay. And you can't see that right now. Let me share that. Okay, I'm sharing it. So here's his elevator state machine. Release elevator, receive elevator. I guess that's in, okay, the floor. And the request elevator, which is the button. So he doesn't have the distinction between up and down in the floor, but that's a good start with the floor state machine. And then he has his elevator state machine. Elevator floor at dock, passengers select floors. Okay, again, that common situation where he's got some states in here, but some of them actually are actions. I guess it could be that you're the elevator, that you're servicing floor requests, which would be moving, I would think. Return to previous state, elevates door from locked. True, false. You see this true, false here. Again, we've got sort of a mixture of state machine and flow chart. Okay. And then we go back to PDFs again. Seems to always work that way. So let me share the PDF viewer again. Okay. So this is Nathan's diagram. So we have elevator, floor, and button as the states. Again, need to fill in the relationships, and again, probably want to have the door involved and the hierarchy between. I guess you might just have a single button. You know, might not have difference between inside and out. But elevator at rest, press button, button illuminates. Okay. Again, this is a flow chart. Very similar. But again, that is a common transition that we need to, looking for a single class and then just the states that class can exist in is what we're looking for. So an interesting thing as I bring up the last submission here is that, and this is PDFs, good, is that I lost my train of thought, sorry. I will come back to that thought when I get there. So here's the UML class diagram. We have an elevator, illumination, and floor. So I assume that's a button in relationship to the button. So this is Logan's submission. Is that right, Logan?
Yeah.
Okay. So you can see here that there's probably a few corrections that we need because illumination is probably the state of the button rather than the button itself. So in the class diagram, you'd want to have the button.
Okay.
And I lost my, oh, here. Here's the elevator state diagram, not moving, up button pushed, down button pushed. Again, it would probably be different arrows, but I get what you're drawing, so that's fine. Waiting for up, waiting for down, elevator, door opened. Waiting for floor state, that's when whether you've gotten to, so yeah. That's a pretty good cut at the elevator diagram. You may have additional states here as well, and then certainly the actions associated with each of the states would be included. But that is a very good start at the elevator. And here's the state diagram for the floor. Waiting for elevator, waiting for floor to be selected. Okay, so elevator state finishes, floor button pressed. Okay, so that will be selected. Waiting for elevator to begin movement. Okay, so again, this may or may not be right. It's sort of illustrating, and so without Logan describing it, I'm not fully getting exactly all the design details. So that's where text in a design document would be helpful, or being presented by the actual author rather than someone just trying to reverse engineer what's going on. But you can see all the different states, verifying floor weight. So that looks good. And then if this were a review, we would just see, okay, do all these events in all these states fully compose of the states that a floor would be in? So, but yes, very good. And then illumination state. Light is off. If false, yeah. So again, this is where it's turning into a flow chart. So your other state diagrams look like state diagrams. This again starting to look more like a flow chart. The fact that you have, I think this is the state diagram for the button. Is that correct?
Yes, it is.
Yeah. So I think there's probably a lot more states that then beyond what I would expect from a button. I expect something more about lit or unlit, unless the design is that the button has the intelligence of controlling the other components, which could be the case. I don't know if it is the case or not, but that's kind of where the flavor that you get from the state, if this was a state diagram for the button, is that the button has all this intelligence about checking if the elevator is at the current target. You could put it into your floor button. Your elevator button. Sorry, the elevator buttons inside your elevator. I wouldn't think that's where the logic would be, but there is no wrong design. It's only decisions about refining and deciding which one works best for you. But certainly this could be an approach that would happen. So that pretty much, we have my 5-minute warning about that we have 5 minutes to go. So do we have any other questions? I think next time I will show you the solution that I threw together. Again, it's not right. and yours isn't wrong necessarily, other than the syntax and notation, that kind of stuff. But then we can go through that and we can treat that as a review and have you look at what I put there and see if you can shoot holes in my design or come away and say, oh, that's right, but maybe this should be done a little bit differently, or maybe I would do this a little bit differently. So any questions about this lecture or about this class?
Yeah, I guess I just wanted to ask, I know that when we were, I think it must have been last session, last class period when we looked at mine, I didn't really hear any critiques from you on the design that I had. So does that mean that if I were to do a similar design for the one on the exam, then that would be something that you would be okay with?
Yes. I don't remember the details of yours, and I might still have. I think I covered. Did I cover? I covered it last lecture, not today, right?
Correct. Mm-hmm.
I seem to recall off the top of my head that you actually did quite a nice job. I'm not sure exactly the design was complete and foolproof, but I think you were on the right track. I seem to recall, and actually, if you look in Canvas at my comments in Canvas about your design, because I believe I graded all of those.
Oh yes, I can do that.
Yes, that would be an indication of what I thought. I didn't necessarily go down to the detail of. Actually, I don't know how much detail I really did go in the comments, so I can go back and give some more detailed comments about your design. But just off the top of my head, Gabe, I believe you did quite a nice job. That you really were getting the concepts. So, yes.
Okay.
But yeah, that's a good point. I will go back and I've already graded those extra credit and given extra credit points. But now I will go back through it and try to add some more illuminating comments regarding it. But hopefully you can take from what I've talked about as we went through this as a class, looking at all the students' diagrams about what things I'm pointing out as mistakes, and so you can see common mistakes, and then hopefully I've been doing as good a job of saying this is very nice, I like how you did this, and take those things into account and say, okay, yeah, I can see what he was doing or she was doing, and saying that's something I want to incorporate in my UML designs. So but yeah, I'll try to go through and add extra comments in on that exercise assignment. So any other questions? Great. Okay, so you are dismissed, and look forward to seeing you on or chatting with you on Wednesday. Take care.